Hello guys, welcome to the NPTEL Control Engineering course, where in this video we are going to discuss the week 1 assignment and their solutions. So first of all, coming on to the first question, which is on the screen. Consider a system yt is equal to xt plus c and xt, yt and c are input, output and constant respectively. So now consider another system zt is equal to xt, where xt is input and zt is output. So which of the following statement is correct? We have to find here that whether system 1 and system 2 are linear or non-linear. So for any system to be linear or non-linear, what we have to do is we have to find out whether the system follows homogeneity and superposition principle or not. So for a system to be linear, we have to check two conditions for a system. First is the superposition. Second is the homogeneity. So the first system, talking about the first system, which is yt is equal to xt plus c, we can clearly see that this particular system does not satisfy the superposition principle. Because according to the superposition principle, if x1 gives y1 output and x2 gives y2 output, then if we apply the input x1, x2, it must give y1, y2 as the output. So if we apply this condition for the first system, we can clearly see that for input x1t, the output we get is y1 is equal to x1t plus c, and for another input x2 we can get y2 is x2 of t plus c. Now if we send the input as x1 plus x2, the y bar output will be x1 plus x2. I'm not writing these t's. So the output for the input x1 plus x2 will be x1 plus x2 plus c. But as we can clearly see that the output for this particular system turns out to be x1 plus c and x2 plus c, which is equal to x1 plus x2 plus 2c, and these two are not equal. So we can clearly say that it does not follow the homogeneity principle. So one thing is clear, that system 1 is non-linear. So we can eliminate some of the options from here. The options such as C option says system 1 and 2 are linear. This is clearly wrong. And this particular option is wrong. Rest all the options A, B and D says system 1 is non-linear. Now we have to check for system 2 also. Now checking for system 2. System 2 is, second system is z of t is equal to x of t. So for first of all we are going to check for superposition. Does it satisfy superposition or not? So for x1, let us suppose the output is z1, and for x2 the output is z2. This implies that for input x1 plus x2, the output should be z1 plus z2. So we can clearly see that if we apply the input x1 plus x2, so instead of xt we are going to replace, x is replaced by x1 plus x2 as x1 plus x2 input is applied. So z of t will be x1 plus x2, which is clearly equal to z1 plus z2. So we can say that this system satisfies superposition. So what about the homogeneous principle? So for checking homogeneity principle, what we are going to do is we are going to check the condition for homogeneity, which is the homogeneity condition is, let us suppose for input x1 the output is z1. Okay, so for instance, now if the input is a times of x1, what we have done is we have simply scaled the input. We have multiplied a constant with the input, so it will provide us with the output, say z dash. So z dash will be equal to a times of z1. If this principle follows, then we can say that second system follows both superposition and homogeneity principle, and we can say that system 2 is linear. So we can clearly see that it satisfies homogeneity principle, because the system is zt is equal to xt, and first of all, let's say input x1 is applied. So we are going to find the corresponding output z1, which will be equal to x1 of t. Now instead of x1 t, input a times of x1 is applied. Then the output, let's say it is z dash, or let's say it is, say the output z bar for the input a x1 will be a x1 of t. Now in place of x1 of t we can put z1 t, so a z1 of t. So clearly this system satisfies the homogeneity principle. So we can say that the system 1 is non-linear and system 2 is linear. So option B in this first question is the correct answer. Moving on to the next question. Okay, so for the given system we have to check whether the system is linear, non-linear, static, dynamic, or causal, not causal. So first of all, we can clearly see that the system carries a quadratic term x squared, so we can say it is non-linear. We don't have to check for the superposition and homogeneity principle. Second, for static and dynamic, so we have to check whether the system is static or dynamic. So for static system, we know that static system are memoryless system. Now the memoryless system means that the output of the system does not depend on the past values. For example, here the output is yt, and if we put t is equal to 1, let us say we are supposed to find the output at t is equal to 1. So y1 will be equal to, let's focus on this second term, it will be x squared of 1, we are going to put t equal to 1, so 1 minus 1, which will be 0, x0 squared. So we can clearly see that output at t equal to 1 is dependent on the input at t equal to 0. So this system is dependent on the past values. So we can say it is a dynamic system, not a static one. Third one, we have to check for the causality of the system, whether the system is causal or non-causal. So for causality, we know that causal system are those systems which are dependent on past and present values, whereas non-causal are those systems which are also dependent on the future values. So this particular system is causal system, and the reason behind it, here we have to do a little bit of improvement. It is t plus 1. So the system is causal because the output yt depends on mainly xt, which is present input, x of t minus 1, which is of course past input, and x of t minus t plus a, and a is a negative. Let us say a value is minus 2, so we can get here t plus of minus 2, which is also a past input. Here we can see that there is no input which refers to the future. So we can say that the output, the system given here is causal system. So the conclusion here we have arrived is the system is non-linear, dynamic, non-linear, dynamic and causal. So option D will be the correct answer. Next question is on the screen, which is consider system yt tx 2t plus 2 where yt and xt are output and input respectively. The system is, we have to find out whether the system is linear or non-linear, time variant or time invariant, or causal or non-causal. So we have to basically check three things for the system. First thing, we have to check is linearity. So we can clearly see that yt is given as tx of 2t plus 2. So for linearity, the system must satisfy both homogeneity and superposition. We can clearly see the nature of system is such that it won't satisfy homogeneity condition or superposition condition. So we can clearly say that the system is non-linear. Linearity condition fails and system is non-linear. Second condition we have to check is time variant or time invariant. Time variance. So the output here is given as yt is equal to t times of x of 2t plus 2. So we can clearly see that the output is not only dependent on the input signal but also the time instant. It is dependent on the time instant also. If this time instant term was not there, suppose the system was something like this, then we could have said that the output, the system here in this case is time invariant. But since this t term is present here, so the system will be time variant. The third condition would be for causality. For causality, we only have to check whether the system is dependent on present or past values only, or it is also dependent on the future values. So for that we will write y is equal to, for instance, what we are given is tx of 2t plus 2. Now if for example we want to calculate the output for t is equal output at t is equal to 1 unit of time. So for that we have to write y is equal to 1 into x of 2 into 1 plus 2. Now here what we get is x of 4. X of 4 is definitely the future input, because at time t is equal to 1, t is equal to 4 will be a future value. So we can say that it is basically a non-causal system. So let's see which option satisfies our non-causal. So let's check which option satisfy all the three conditions. So first of all, non-linear, time variant and non-causal. So non-linear, time variant, C option will be the correct answer. Moving on to the next question. So next question is, which of the following term represent the loss of energy in the model equation of a cruise control for a car whose dynamics is given as V dot plus B upon mv is equal to F upon m. Now this particular equation is arrived when this mv dot plus bv is equal to F, where F is the external force applied on the car for the acceleration, B is the force of inertia which applies in the opposite direction of the external force, and B into V is of course the frictional force which accounts for the energy loss. So we can clearly see this equation has been divided by m throughout, and the term which represents the energy loss is given by Bv upon m. So option B will be correct answer. So moving on to next question. It is in order to get the time period of a simple pendulum as half the initial time period, the length of the string should be. Now the time period of the oscillation is given by 2 pi root L upon G, where G is acceleration due to gravity and L is given as length of string. Now in order to get time period as half the initial time period, let the time period be t dash, which is half of the initial time period. So for that time period, let the length be L dash. Now put t is equal to 2 pi root L upon G is equal to 2 pi root L dash upon G. 2 pi got cancelled. G root L is equal to 2 root L dash, and L dash value will be equal to L upon 4. So A option will be correct answer, 1 upon 4 of its initial length. Moving on to next question. So the next question, we are given a system which is attached with a damper spring K1, and so we have to write the equation, we have to select the correct model for the correct equation model for the given system. So first we have to account what forces are acting on the system. Let's just undo. Okay. So the forces which act on the, first of all, this external force U. The first force which acts is U. Second force we can say will be due to damper, because the displacement of the card is in right direction. We can clearly see here, which is denoted by y1. So if the card displacement is towards the right, then the force due to damper will be towards the left, and it will be given by B times y double dot. V times of y1 dot. And the third force which is due to spring, which will be K times of y1. And the fourth force will be due to inertia, which will be equal to m1 y1 double dot. Now we can clearly see that all four options consist of these forces. So what will be the signs of these forces? All we have to do is compute the various signs, whether it will be positive or negative. So we can clearly see that all three forces, force number 2, 3 and 4, all lie in the same direction, which is left. Only one force, which is the external force, lies in the right direction. So we can say that all the forces will be of same sign, which is positive. B option will be correct. So the next question is, consider the electric circuit shown below. Which of the following differential equation represents the voltage Vt dynamics? So to calculate voltage Vt dynamics, simply KVL we have to apply. So applying KVL in the first mesh. First mesh is only this part. Okay. So if we apply KVL, what we get is Vt minus R1 I1t minus L di by dt of I1 minus I2 is equal to 0. Now if we rearrange the following terms, we get R1 I1t minus L di1 by dt plus L di2 by dt is equal to hang on, it will be positive and this one will be negative. Equal to Vt. So it matches second option, which will be correct answer. Question number 8 is, what is the equation pertaining to Kirchhoff's current law at node 1 in the following circuit? Simply we have to apply KCL at node 1. So incoming current would be I, which is equal to outgoing current. Outgoing current, if we are given voltage across resistance as V, then V upon R, and current across the inductor would be, see, the current across the voltage across the inductor is given by L di by dt. So we want current across the inductor. So VL dt is equal to 1 upon L is thrown here, and di I will be equal to 1 upon L integration V dt. So we will get plus 1 upon L integration V dt. Option C will be the correct answer. So the ninth question we are given is related to the predator-prey model, which we have studied in the module 1. The dx by dt and dy by dt equations are given, and we have to find the equilibrium points. Okay. The option B is given, x equal to minus infinity, y is equal to 0. So for finding equilibrium points are the points where the variables x and the variable y cease to change, which basically means that dx by dt and dy by dt is equal to 0. So we put the dx by dt equation, 5x minus 2x square minus 4xy is equal to 0, and on the other hand we put y minus 3y square plus xy is equal to 0. Here we can see x common, 2x minus 4y is equal to 0, and here we can take y common. So 1 minus 3y plus x equal to 0. One of the solution is x equal to 0 and y equal to 0. Here we are clearly given that the equilibrium points, the point may be one or it may be multiple points. So one option, the option A, is definitely correct. Now we have to look for other solutions also, because there might be some other values of x and y where they are constant. So we are given 5 minus 2x minus 4y is equal to 0 and 1 minus 3y plus x equal to 0. If we solve these two equations, which are equation in two variables, we get x equal to 11 upon 10 and y is equal to 17 upon 10, which is option C. So in this question, option A and C are correct. So the last question, it says that consider the predator-prey model in the previous question. What happens when the number of preys are 0? So the equation that were given were dx by dt is equal to 5x minus 2x square minus 4xy, and dy by dt is equal to y minus 3y square plus xy, where x is the number of prey and y is the number of predators. Now in this question we are being said that the number of preys are getting 0. So value of x is getting 0. So the population of predators, what happens to the population of predators? So if we look at the second equation, dy by dt equal to y minus 3y square plus xy, if we put x equal to 0, this term becomes completely 0, and dy by dt term will be equal to y minus 3y square. So to find the equilibrium value, we put dy by dt is equal to 0. So y minus 3y square equal to 0. Taking y common, 1 minus 3y is equal to 0. we get y is equal to 0 and y is equal to 1 by 3. Y is equal to 0 solution is rejected and y is equal to 1 by 3 is solution that we get. So we can say that population of predator reaches to a constant asymptotically. Option B will be the correct answer.